All right, we are here to do a video walkthrough of practice quiz number 2 for learning target number 2, transformations. So to start, let's take a look at standard 2.1. Identify the transformation as a reflection, rotation, or translation. Now, when we're looking at that, reflection, that is a flip. A rotation is a spin or a turn. And a translation is a slide. So let's look at the fish over here. So the fish first. What happened to this fish? Well, it looks like started here and I went, so it flipped over the x-axis. If we can see the fish is flipping, that means it is a reflection. For the second one, we have two triangles here, triangle A, B, and C. Triangle A prime, B prime, C prime. So we can see this triangle slid down there. That means it is a translation. Lastly, these two hearts. Well, they didn't slide because they're pointing different directions. Did they flip over something? Is there reflection symmetry? Not exactly. But what you can see is that if you look at this heart, it almost looks like it was spun around to now be upside down. That making it a spin, therefore it is a rotation. All right, let's move on down to Golden Standard 2.2, drawing transformations. So for this one, translate the figure down 1 unit and left 4. So we're going to take each point like J, and we're going to go down 1 unit and to the left 1, 2, 3, 4. And making this point J prime. I, down 1, left 1, 2, 3, 4. Make sure you're counting the lattice points, not the boxes in between. Down 1, 1, 2, 3, 4 to the left. M prime. Connect the dots to draw our image. All right, rotate the figure 270 degrees clockwise around the origin. Now, clockwise, that means we're going to go like a clock, so we're going to go this way. 270 degrees means we're going to go 90, 180, 270. So it's going to end up down in this quadrant down here, 3/4 of the way around a circle. So what you want to do is trace your shape. I've already got it done here. So you trace the shape, label your points, and also make sure to put a dot at the point of rotation, the origin, 0, 0. I really like to draw a couple of these little crosshairs right here, this little axis. That shows me when I've rotated exactly 90, 180, or 270 degrees. Take your pencil, hold it tight right there at the point of rotation, and spin your tracing paper. So here is 90 degrees. You can see how the central axes have lined back up. Here is 180. Again, you can see how it's lined back up. And finally, 270. It's going to be right there. To push it through onto your paper, push really hard on the tracing paper, color really hard right there, and you'll see it show up on your paper. So I can see the little dents from here to here. Sorry, missed a little bit. Try to be more precise. So it should look like that. So then we got to figure out where our points are. We can see that there's L, Z, and J. So J prime, L prime, and Z prime. That is a 270 degree rotation, which is the same as a 90 degree counterclockwise rotation. All right, let's reflect the figure over the y-axis. First step, the y-axis, where's the y-axis? Right here. So we're going to reflect over that line right there. First step, trace it. And I also am going to encourage you to trace the line of reflection. Label your points. Now reflect, our keyword is flip, so we're going to flip our tracing paper over, line our line of reflection back up, and we can see where our reflected triangle will be, just like that. All right, flip it over, look at your paper, and connect your points. Last step, label them with prime notation. M prime. You can see the reflection symmetry there as it is flipped over that line of reflection. That's Golden Standard 2.2. Let's move on to the back. So on the back here, we have to describe the transformation we see in words and algebraically. So first step, identify the pre-image and the image. The image, the result, will have prime notation. Notice the primes there, 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 making this the image. That's our result, making this the pre-image. We start here, end here. So first step, did it slide? Did it translate? No, because the orientation changed, the direction changed. So it can't be a translation. Did it flip? Is there reflection symmetry? No. So therefore, is it a rotation? Did this spin around? Yeah, it spun. If you turn your paper, you can see the same shape. All right, check this out. If I turn it, see how this looks like? Kind of looks the exact same as that. That's a trick to tell, is it a rotation? So we know it's a rotation. How far did it go from here to here? Well, it's about a quarter turn of our paper makes it look the same. So that means it is 90 degrees. What direction is going this way? That's going to be clockwise. And last thing, around 0, 0. Okay. Now, algebraically, what does that look like? The key is to look at your points. So, for example, what are the coordinates of x? -6, 2. What are the coordinates of x prime? 2, 6. What are the coordinates of y? -2, 4. What are the coordinates of y prime? 4, 2. What do you notice is happening? What's the pattern? What do you see? Well, I see 6, 2 becomes 2, 6. 2, 4 becomes 4, 2. X and y are flipping. They are changing positions. So xy becomes y, x. Is that all that happens? Well, 2, 4, 2, 4. The second number becomes the first number, and nothing changes. So y becomes y. Same thing. But what happens with the x? -2, -6 becomes +6. -2 becomes +2. The sign is changing, negative to positive. How do we indicate a sign change? -x. Multiplying by a -1 changes the sign of a number. All right, let's take a look at the next one. What do we see here? Well, I see the pre-image up here and the image down here. Notice the prime notation. So I took a shape, and it looks like it flipped like that. So if it flipped, that's how I know I'm going to call it a reflection. Now reflection, I need over what line? It reflected over this line right here, which is the x-axis. Again, to check the rule, test your points. All right. So for example, I see that A is at 2, 1, and A prime is at 2, -1. For B, I see B is at 4, 1. I see B prime is at 4, -1. What pattern are you noticing? 2, 2, 4, 4. The x's stay the same. The first number, the x value, stays the same. What happens to the y value? 1, -1. 1, -1. The sign changes just like it did up here. So instead of y, it's going to become -y. We're going to change the sign of the y coordinate. That is a flip, a reflection over the x-axis. All right, last one. 2.4, describe a sequence of transformations for this right here. So how do we do this? We got to figure out a way to get this pre-image to match up perfectly with that image. So first step, there are infinite combinations we could do. So many different ways to arrive at the ending location. One possible way I'm seeing is it looks like we got to like spin this triangle around. I don't like that it's kind of not lined up the same way. So let's spin it around a little bit. Let's rotate it. Now, how far do I want to rotate it? I want to make it so that this segment right here has the same orientation as this segment right here. I want it to be going up and down. So I want to spin this 90 degrees, and I'm going to spin it to the right so that way it's going up and down. So we're going to spin clockwise around 0, 0. So that's going to be step one. Where is that going to be located? That's going to be located right around here. And I'm going to draw this pretty quick. This is it. 4, 7. I've got it already down. So it's going to look like that. Okay. Well, now it's kind of oriented the right way. Like I got this side right here lined up like I want it. Okay. So But it looks like I need to get this triangle to flip down, so that way it's like pointing up and not pointing down. So I'm going to flip it over. So my second step I'm going to do is to reflect over the x-axis. So this was step one. For step two, I'm going to flip over the x-axis. It's going to end up right here. Again, you can see that this segment right here is right here. All right. Last thing, I got to move it. It looks like we're perfectly lined up. It just needs to be moved to the right location. So I'm going to slide it up by translating. So I'm going to translate 1, 2, 3 up, 3 units up, and 1 unit left. 3 steps. So that will end us right there. How do we write this algebraically? They're not different. They all need to be combined. So our first step, x comma y, 90 degree clockwise. We saw that up above. We saw that in this question right here. So you could always check the points, but for just right now, we're just going to make it y comma negative x. That's always the rule for a 90 degree clockwise rotation. Now for step 2, I don't start with xy. xy describes the location of the points here. I'm at here now. I'm at y comma negative x. So to move from here to here, I didn't reflect from here to here. I reflected from after step 1. So step 2's algebraic rule starts from the end of step 1. So I start here, y comma negative x. Now, when you reflect over the x-axis, what happens? The y value, but it's x, Mr. Aha. This x just stands for the original x-coordinate. This second number after the comma always represents the y value. That y value becomes negative. So that means it's y comma negative x. I'm changing the sign of the y value. Notice it's like 4 comma 7 becomes 4 comma negative 7. 4 comma 4 becomes 4 comma negative 4. This second y value, this y value right here, I know it says x. It is a y coordinate. The x is just a placeholder for a number. It changes sign again. So you could write it like that, or you could write it as just y comma x, because a negative times a negative is a positive. Now we got one more step to do. We have to translate. Now again, we're going to start with the end of step 2. So I'm going to start at y comma x. And that becomes, when you do 3 units up, careful. You're going to want to do y plus 3 because up goes with the y. 3 is up. That's about our y coordinate, which is the second number in our coordinate point system. Okay? The second number in our coordinate point system here is the y coordinate. Even though it says x, it's in the y coordinate position. So this moves it 3 up. 1 unit to the left means I take my x coordinate and move it 1 to the left. How can you say x coordinate when there's a y right there? This y refers to the original y value. All right, that's just a placeholder for a number. It's the x coordinate, and we're going to move it 1 to the left. So our final answer here is right here. That's our final algebraic rule. Could you find that by just comparing the points from your pre-image to your image? Absolutely. You could make a table from here to here, and this would be the rule you would see. It's really hard to figure out from just a table. I'd recommend trying to look one step at a time. All right, good luck. Hope it goes well for you.